In the bit first question, d square plus 1 into y equals to sin x into sin 2x. So first the auxiliary equation is m square plus 1 equals to 0, m square equals to minus 1, then m equals to root minus 1, m equals to plus or minus I. So the roots are complex numbers, so here is a complementary function for the complex numbers. Let's compare with alpha plus or minus I beta, alpha value 0 and beta value 1. So then e to the power of 0 into x, c1 into cos x plus c2 into sin x, and e to the power of 0 x is 1. So then c1 into cos x plus c2 into sin x is a complementary function. Now the particular integral is x divided by f of d. So x value is sin x into sin 2x divided by f of d, that is d square plus 1. So it is equals to, here apply the 2 sin a into sin b formula, that is cos a minus b, cos a minus b minus cos a plus b. From this, sin a into sin b equals to 1 by 2 bracket of cos a minus b minus cos a plus b. So then here 1 by 2, 1 by d square plus 1, 1 by 2 into cos a minus b, that is 2x minus x minus cos a plus b, 2x plus x. So it is equals to 1 by 2 bracket of cos 2x minus x is x by d square plus 1 minus cos 2x plus x is 3x by d square plus 1. So it is equals to 1 by 2 bracket of here cos x by d square plus 1 can write as a 1 square minus cos 3x by, here substitute d square equals to minus a square, so a value 3, so minus 9, so minus 9 plus 1. So it is equals to 1 by 2 bracket of, here the suitable formula is cos ax divided by d square plus a square, it is equals to x by 2a into sin ax. Here a value is 1. So x by 2a, x by 2 into 1 sin 1 into x minus, here minus 9 plus 1 minus 8, and here minus is there, then overall plus cos 3x divided by 8. So it is equals to, so 1 by 2 multiply inside, x divided by 2 2s are 4 sin x plus cos 3x 1 by 16 into cos 3x is a particular integral. Now the general solution is complementary function plus particular integral. Complementary function is c1 into cos x plus c1 into cos x plus c2 into sin x, and particular integral is x by 4 into sin x plus 1 by 16 into cos 3x is our required answer. Next question, d square plus 5d minus 6 into y equals to sin x into sin 4x. So the auxiliary equation is m square plus 5m minus 6 equals to 0. So m square plus 6m minus m minus 6 equals to 0. Take the m common, m plus 6 minus 1 common, m plus 6. Now m plus 6 is a common into m minus 1 equals to 0. So m plus 6 equals 0, m minus 1 equals 0, m equals to minus 6, m equals to 1. So here the roots are real and different. Then c1 into e to the power of m1x plus c2 into e to the power of m2x. So then the complementary function is c1 into e to the power of, first take the 1, c2 into e to the power of minus 6x. Now the particular integral is x divided by f of d. So here x means sin x into sin 4x divided by f of d square plus 5d minus 6. So now here apply the sin a into sin b formula, that is 1 by 2 bracket of cos a minus b minus cos a plus b. So it is equals to 1 by d square plus 5d minus 6 into 1 by 2 bracket of cos a minus b 4x minus x minus cos 4x plus x. So it is equals to 1 by d square plus 5d minus 6. So here 1 by 2. So cos 4x minus x is 3x minus cos 4x plus x is 5x. So 1 by 2 bracket of, split into two fractions, cos 3x by d square plus 5d minus 6 minus cos 5x by d square plus 5d minus 6. So 1 by 2 bracket of, here substitute d square equals to minus a square. So a value is 3, so minus 9. Here also substitute d square equals to minus a square, but a value is 5, so minus 25. So then cos 3x divided by minus 9 plus 5d minus 6 minus cos 5x divided by minus 25 plus 5d minus 6. So it is equals to 1 by 2 bracket of, so cos 3x by 5d minus 9 minus 6 is minus 15. Now multiply with 5d plus 15, 5d plus 15 and divide with 5d plus 15. Next minus cos 5x divided by 5d minus 25 minus 6 minus 31. So then multiply with 5d plus 31, divide with 5d plus 31. So it is equals to 1 by 2 bracket of, so 5d plus 15 into cos 3x divided by 5d whole square minus 15 square. Next to minus 5d plus 31 into cos 5x by 5d whole square minus 31 square. Then it is equals to 1 by 2 bracket of, here 5d into cos 3x plus 15 into cos 3x, but d nothing but derivative. So that is why 5 into cos 3x derivative minus sin 3x into 3 plus 15 into cos 3x divided by 25 d square. What is the d square value here? D square value minus 9 minus 15 square is 225. So minus here also 5d into cos 5x plus 31 into cos 5x. So 5d 5 into cos 5x derivative minus sin 5x into 5 plus 31 into cos 5x divided by 25 into here d square value minus 25 minus 31 square 961. So 1 by 2 bracket of 5 3s are 15 minus 15 sin 3x plus 15 cos 3x divided by 25 into 9 minus 225 minus 225 minus 225 minus 450. Next to minus bracket of 5 5 is a 25 sin 5x plus 31 cos 5x divided by 25 into 25 minus 625 and minus 625 plus 961 6 8 15 minus 1586 minus 1586. So it is equals to 1 by 2 bracket of, let's take the minus common in the numerator and that minus will cancel with the denominator. So 15 cos, so let's take the minus 15 common, minus 15 sin 3x minus cos 3x divided by minus 450 minus here minus then it will become plus. So 1 by 1586. Next here I am writing the first positive term cos 5x minus 25 sin 5x. So it is equals to 1 by 2 bracket of here minus minus cancel, 15 ones are 15 3s are 45 and here 0. So 1 by 30 bracket of sin 3x minus cos 3x plus 1 by 1586 bracket of 31 cos 5x minus 225 sin 5x. So this is a particular integral. Now let's write the general solution. So the general solution is complementary function plus particular integral c1 into e to the power of x plus c2 into e to the power of minus 6x plus 1 by 2 bracket of 1 by 30. So this is our required answer. 18th bit first question, d square minus 4d plus 13 into y equals to 8 sin 3x, y of 0 equals to 1, y dash of 0 equals to 2, and the b question also same. Okay, so first the auxiliary equation is m square minus 4m plus 13 equals to 0. So here to find out the m value, use a formula because factorization is not possible, divided by 2a. So minus b value minus 4 plus or minus 4 whole square minus 4 into a value 1 and c value 13 divided by 2 into 1. 4 plus or minus under root 16 minus 4 13s are 52 divided by 2. 4 plus or minus 16 minus 52 is minus 36 divided by 2. So 4 plus or minus root 36 is I into 6 by 2. Take the 2 common in the numerator. So 2 cancel, then m equals to 2 plus or minus I into 3. So now the roots are complex numbers, then the complementary function is e to the power of alpha x into c1 into cos beta x plus c2 into sin beta x. So compare with alpha plus or minus I beta, alpha value 2, beta value 3. So then the complementary function is e to the power of 2x into c1 into cos 3x plus c2 into sin 3x. Now the particular integral is x divided by f of d. So x value is 8 into sin 3x divided by f of d value is d square minus 4d plus 13. So 8 into sin 3x divided by sin 3x divided by, substitute d square equals to minus a square. So minus a value is x coefficient, that is 3. So minus 9. So minus 9 minus 4d plus 13. So it is equals to 8 into sin 3x by minus 4d, minus 9 plus 13 is plus 4. Now let's take the minus 4 common in the denominator. So then d minus 1. 4 ones are 4 twos are. So minus 2 sin 3x by d minus 1. Now multiply with d plus 1 and divide with d plus 1. So it is equals to minus 2 into d plus 1 into sin 3x by d square minus 1 square, minus 2 into d into sin 3x, 1 into sin 3x. D means derivative. So derivative of sin 3x is cos 3x into 3 plus 1 into sin 3x is sin 3x by d square. So substitute the d square as a minus 9 minus 1 square is 1. So minus 2 by minus 10, 3 into cos 3x plus sin 3x. Here minus minus cancel, 2 ones are 2 5s are. Then the particular integral is 1 by 5 bracket of 3 cos 3x plus sin 3x. Now let's write the general solution. Y equals to complementary function plus particular integral. So here is a complementary function. Complementary function e to the power of 2x into c1 into cos 3x plus c2 into sin 3x. Next particular integral is 1 by 5 bracket of 3 cos 3x plus sin 3x. So this is the answer for B question. So but in the A question he was given two conditions, y of 0, y dash of 0. Using these two conditions you have to find out the constant c1 and c2 values. Okay. So given that y of 0 equals to 1, y of 0 equals to 1 means x equals 0, then y equals to 1. So 1 equals to, substitute this value in this, 1 equals to e to the power of 2 into 0 c1 into cos 3 into 0 plus c2 into sine 3 into 0 plus 1 by 5 into 3 into cos 3 into 0 plus sine 3 into 0. So 1 equals to e to the power of 2 into 0 is 0, e to the power of 0 is 1, c1 into cos 3 into 0 is cos 0, c2 into sin 3 into 0 sin 0 plus 1 by 5, 3 into cos 3 into 0, 3 into cos 0 plus sin 0. 1 equals to c1 into cos 0 is 1, cos 0 is 1 plus c2 into sin 0 is 0, 1 by 5 into 3 into cos 0 is 1, sin 0 is 0. 1 equals to c1 plus 1 by 5 into 3. So it is equals to 1 minus 3 by 5 equals to c1. So the LCM is 5, 5 minus 1, 3, 2 by 5 is a c1. Now one more value given, that is y dash of 0 equals to 2. Y dash means derivative of a y function with respect to 0 with respect to x. So let's find out the dy by dx. Okay, so here it is a two functions are there, product of two functions. Product of two functions means you have to apply the formula, that is d of u into v equals to u into dv by dx plus v into du by dx. Okay, so e to the power of 2x into d by dx of c1 into cos 3x plus c2 into sin 3x plus next c1 into cos 3x plus c2 into sin 3x. Next also derivative of 1 by 5 bracket of 3 into derivative of cos 3x is minus sin 3x into 3 plus derivative of sin 3x is cos 3x into 3. So it is equals to dy by dx, nothing but y dash of x equals to e to the power of 2x into derivative of cos 3x is minus sin 3x into 3 into 3 plus c2 into sin 3x, that is cos 3x into 3 bracket close plus c1 into cos 3x plus c2 into sin 3x, and derivative of e to the power of 2x is e to the power of 2x into 2 plus 1 by 5 bracket of minus 9 sin 3x plus 3 into cos 3x. So y dash of x equals to e to the power of 2x here minus 3c1 sin 3x plus 3c2 cos 3x plus 2 into e to the power of 2x, c1 into cos 3x plus c2 into sin 3x plus 1 by 5 bracket of minus 9 sin 3x plus 3 into cos 3x. Now we have to use the second condition. What is that? Given that y equals to y dash of 0 equals to 2. So then 2 equals to y dash of 0 equals to means x value 0 and y dash value 2. So e to the power of 2 into 0 minus 3c1 into c1 value how much? 2 by 5 sin 3 into 0 plus 3 into c2 into cos 3 into 0 plus 2 into e to the power of 2x c1 value 2 by 5 cos 3 into 0 plus c2 into sin 3 into 0 plus 1 by 5 minus 9 sin 3 into 0 plus 3 cos 3 into 0. It is equals to e to the power of 2 into 0 is e to the power of 0. Its answer is 1. So then minus 3 to the 6 by 5. Sin 3 into 0 is sin 0. Sin 0 value 0 plus 3 c2 cos 3 into 0 cos 0. Cos 0 value 1. Next to plus e here we did not substitute the here 2 bracket of 2 by 5 cos 3 into 0 cos 0 value 1 plus c2 into here sin 3 into 0 sin 0 value 0 plus 1 by 5 bracket of minus 9 into sin 0 plus 3 into cos 0 is 1. 2 equals to here 3c2 plus 4 by 5 minus plus 3 by 5. So 2 equals to 3c2 4 plus 3 7 by 5. So 2 minus 7 by 5 2 minus 7 by 5 equals to 3c2 5 2s are 10 3 by 5 equals to 3c2 3 cancel, then c2 value 1 by 5. And what is the c1 value? 2 by 5. So substitute these two values in our general solution. So the general solution already we found, that is, so this is a general solution. In this substitute the c1 and c2 values. 2 by 5 into cos 3x plus 1 by 5 into sin 3x plus 1 by 5 into sin 3x plus 3 into cos 3x 3 into cos 3x. So y equals to, here we can take the 1 by 5 common, e to the power of 2x into 2 cos 3x plus sin 3x plus 1 by 5 into sin 3x plus 3 cos 3x. So we can take 1 by 5 common overall, e to the power of 2x into 2 cos 3x plus sin 3x plus sin 3x plus 3 cos 3x is our required answer. Next question, d square minus 4d plus 13 into y equals to 3 sin 3x. So the auxiliary equation is m square minus 4m plus 13 equals to 0. Let's do factorization. So the roots are 2 plus or minus I into 3. So they are complex numbers. So for the complex numbers, complementary function is e to the power of alpha x. Alpha means 2. E to the power of 2x bracket of c1 into cos beta x, beta value 3, plus c2 into sin beta x. So this is a complementary function. Now let's find out the particular integral, that is x divided by f of d. So x value is 3 sin 3x divided by f of d, that is d square minus 4d plus 13. So here substitute d square equals to minus a square. So minus a value is x coefficient, that is 3. So minus 9. So 3 into sin 3x divided by minus 9 minus 4d plus 13. So 3 into sin 3x divided by minus 4d minus 9 plus 13 is plus 4. So now let's take the minus 4 common in the denominator. So 3 by minus 4 sin 3x divided by d plus d minus 1. Now multiply with d plus 1, divide with d plus 1. So minus 3 by 4 d plus 1 into sin 3x divided by d square minus 1 square. So it is equals to minus 3 by 4. Here sin d into sin 3x means derivative. So minus 3 bracket of derivative of sin 3x is cos 3x into 3 plus 1 into sin 3x divided by d square value is minus 9 minus 1, here by 4. Next to minus 9 minus 1 minus 10, and minus minus will cancel. Then 4 into 10 is 40. 4 into 10 40 bracket of 3 cos 3x plus sin 3x. Now let's write the general solution. Complementary function plus particular integral. So e to the power of 2x bracket of c1 into cos 3x plus c2 into sin 3x plus 3 by 40 bracket of 3 into cos 3x plus sin 3x. This is our required answer. Next question, 19th bit first problem, d square minus a square into y equals to e to the power of minus ax plus sin ax. So the auxiliary equation is m square minus a square equals to 0, m square equals to a square, then m equals to under root a square, then m equals to plus or minus a. So then the complementary function is e to the power of c1 into e to the power of minus ax plus c2 into e to the power of plus ax. Now the particular integral is x divided by f of d. So x value is e to the power of minus ax plus sin ax divided by d square minus a square. Now split into two fractions, e to the power of minus ax by d square minus a square plus sin ax divided by d square minus a square. So then it is equals to e to the power of minus ax by, here substitute d equals to minus a. So minus a whole square minus a square. Minus a whole square is plus a square. Then the denominator will be a 0. That is why do derivative with respect to capital D. So d square minus a square and multiply with x. Next to plus sin ax divided by, here at the place of d square you have to substitute minus a square. Then it is equals to x into e to the power of minus ax by derivative of d square minus a square is 2d plus sine ax divided by minus a square minus 2a square. Now substitute d equals to minus a, 2 into minus a minus 1 by 2a square into sine ax. So x into e to the power of minus ax by minus 2a minus 1 by 2a square into sine ax. So then the particular integral is minus x e to the power of minus x by 2a minus 1 by 2a square sine ax. Do one thing, let's take the LCM. Here LCM is what? 2a square is a LCM, 2a square. Then here 1a will come in the numerator, ax into e to the power of minus ax minus sine ax. Now take the minus 1 by 2a square common, then ax into e to the power of minus ax plus sine ax. So now the general solution is complementary function plus particular integral. So the complementary function is c1 into e to the power of minus ax plus c2 into e to the power of ax minus 1 by 2a square bracket of ax into e to the power of minus ax plus sine ax is our required answer. Second question, d square plus a square into y equals to e to the power of ax plus cos ax. So the auxiliary equation is m square plus a square equals to 0, then m square equals to minus a square, m equals to under root minus a square, then m equals to plus or minus I into a. Then the complementary function is here complex numbers, so then e to the power of compare with alpha plus or minus I beta, then alpha value 0, beta value a, then here 0 will come because complementary function is e to the power of alpha x into c1 into cos beta x, that is a, plus c2 into sin beta x, c2 into sin beta value a x. So this is here e to the power of a into x is 1, then c1 into cos ax plus c2 into sin ax. Now the particular integral is x divided by f of d. The x value is e to the power of ax plus cos ax divided by d square plus a square, then split into two fractions, d square plus a square plus cos ax divided by d square plus a square. So here substitute the d value as a, then a square plus a square, and here the formula is x by 2a into sin ax. So e to the power of ax by a square plus a square 2a square plus x by 2a into sin a. This is a particular integral. Now the general solution is y equals to complementary function plus particular integral. So y equals to c1 into cos ax plus c2 into sin ax plus e to the power of ax by 2a square plus x by 2a into sin ax is our required answer. Question number 20, d square plus 6d plus 9 into y equals to sin x, where y equals to y dash equals to 0 if x equals to 0. So the auxiliary equation is m square plus 6m plus 9 equals to 0. Now do factorization. So here the roots are real and equal, then the complementary function is c1 plus c2 into x e to the power of mx, so m value minus 3. So this is a complementary function. Next to the particular integral is x divided by f of d. So x value is sin x divided by d square plus 6d plus 9. So here substitute d square equals to minus a square. Here a value is x coefficient, so minus 1. So minus 1 plus 6d plus 9. So sin x divided by 6d minus 1 plus 9 is plus 8. Now sin x by, here multiply with the 6d minus 8, 6d divided with the 6d minus 8. So then 6d minus 8 into sin x by 6d whole square minus 8 square. So 6d sin x means derivative of sin x, so 6 into cos x minus 8 into sin x by 6 square 36, and d square value minus 1 and 8 square is 64. So 6 cos x, here we can take the 2 common in the numerator, cos x minus 3 cos x minus 3 cos x minus 4 sin x by 36 into minus 1 minus 36 minus 64 is minus 100. 2 ones are 2, 50 is a, so then the particular integral equals to minus 1 by 50 bracket of 3 cos x minus 4 sin x. Otherwise let's take the minus common in this, so minus or minus plus, so 1 by 50, when you taking the minus common, the 4 sin x will come first. 4 sin x minus 3 cos x. Now the general solution is complementary function plus particular integral. The complementary function is c1 plus c2 into x e to the power of minus 3x plus particular integral 1 by 50 bracket of 4 sin x minus 3 cos x. Now we have to find out the c1 and c2 values by using these values. Given that here y equals to 0 when x equals to 0, so substitute these two values in this. Okay, let's draw one table for this. It is equals to 0 equals to c1 plus c2 into 0 e to the power of minus 3 into 0. Next plus 1 by 50 into 4 into sin 0 minus 3 into cos 0. 0 equals to, here c1 c2 into 0 0, and e to the power of 0 is 1 plus 1 by 50 into 4 into sin 0 is 0, cos 0 is a 1, so then here minus 3 will come. So 0 equals to c1 minus 3 by 50, then c1 equals to 3 by 50. Now one more value, y dash equals to 0 if x equals 0. First of all, find out the derivative of the function y with respect to x. Here is a function y, so what is that? Here it is a product of the two functions, then c1 plus c2 into x, okay, d by dx of e to the power of minus 3x plus e to the power of minus 3x into d by dx of c1 plus c2 into x. Next plus 1 by 50 bracket of 4 into sin x derivative is cos x minus cos x derivative is minus sin x, so minus into minus plus 3 sin x. So dy by dx equals to c1 plus c2 into x, c1 plus c2 into x. Derivative of e to the power of 3x is e to the power of minus 3x into minus 3 plus e to the power of minus 3x into derivative of c1 plus c2x is c1 is 0 and c2x will become just a c2. Next to 1 by 50 bracket of 4 cos x plus 3 sin x. Now the given that y dash equals to 0 and x equals to 0. Y dash means dy by dx. So let's substitute these values. So 0 equals to c1. c1 value we already completed, that is 3 by 50 plus c2 into 0 e to the power of minus 3 into 0 into minus 3 plus e to the power of minus 3 into 0 into c2 plus 1 by 50 bracket of 4 into cos 0 plus 3 into sin 0. So 0 equals to minus 3 by 50 into e to the power of 0 is 1 into minus 3 plus here e to the power of 0 is 1 c2 1 by 50 into cos 0 is a 1 and sin 0 is a 0, then overall it is 4. 0 equals to minus 9 by 50 plus c2 plus 4 by 50. 0 equals to minus 9 by 50 plus 4 by 50 minus 5 by 50 plus c2. So c2 equals to 5 by 50. So now substitute c1 and c2 values in the general solution. Okay, the general solution is what y equals to. So this is a general solution. In this, substitute the c1 and c2 value. c1 value 3 by 50, c2 value 5 by 50. Then overall we can take the 1 by 50 common. Then c1 3, c2 5x e to the power of minus 3x plus 1 by 50 bracket of 4 sin x minus 3 cos x is our required answer. 21st question, y double dash plus 4y dash plus 4y equals to 4 cos x plus 3 sin x. Y of 0 equals to 1, y dash of 0 equals to 0. So the symbolic form of the given quadratic equation is here d square plus 4d plus 4 into y equals to 4 cos x plus 3 sin x. Now the auxiliary equation is m square plus 4d 4m plus 4 equals to 0. Now do factorization. So the roots are real and equal. Then the complementary function is c1 plus c2 into x e to the power of minus 2x. Now the particular integral is x divided by f of d. So the x value is 4 cos x plus 3 sin x divided by f of d value d square plus 4d plus 4. So here split into two fractions. So 4 into cos x divided by, here substitute d square equals to minus a square. So a value is x coefficient, here also same x coefficient is 1, so minus 1. So here minus 1 plus 4d plus 4 plus 3 sin x divided by minus 1 plus 4d plus 4. So 4 cos x by 4d plus 3 multiply with 4d minus 3 divide with 4d minus 3. 3 into sin x divided by, here also same 4d plus 3, then multiply and divide with 4d minus 3. So it is equals to 4 into 4d minus 3 into cos x divided by 4d whole square minus 3 square. Here 3 into 4d minus 3 into sin x divided by 4d whole square minus 3 square. 4 into 4d cos x means 4 into derivative of cos x is minus sin x minus 3 cos x divided by 16d square minus 1 minus 3 square 9 plus 3 into 4d minus 3, 4d into sin x, 4 into cos x, derivative of sin x is cos x, minus 3 sin x divided by 16 into d square minus 1, 3 square 9. So it is equals to 4 by 16 into minus 1 minus 16 minus 9 minus 25 total. And in the numerator we can take the minus common, so minus denominator minus, both are cancelled. Then in the 4 by 25 bracket of 4 sin x plus 3 cos x. Next here also minus 25, so minus 3 by 25 bracket of 4 cos x minus 3 sin x. Now take the 1 by 25 common, so and 4 multiplied inside, 16 sin x, 4 3s are 12 cos x minus 3 4s are 12 cos x, minus into minus plus 9 sin x. Here plus 12 cos x minus 12 cos x cancel, 1 by 25, 16 sin x plus 9 sin x is 25 sin x, 25 cancel, then the particular integral is sin x. So now the general solution is complementary function, that is c1 plus c2 into x e to the power of minus 2x plus particular integral is sin x. So now given that y of 0 equals to 1, y of 0 equals to 1 means y equals to 1 when x equals to 0. So substitute these values in the general solution. So 1 equals to c1 plus c2 into 0 e to the power of minus 2 into 0 plus sin 0. 1 equals to c1 e to the power of 2 into 0 is 1 and sin 0 is 0. So overall C1 value is 1. Next, one more value given, y dash means derivative. Let's do derivative of the general solution. Here apply the u into v formula. C1 plus C2 into x d by dx of e to the power of minus 2x plus e to the power of minus 2x into d by dx of c1 plus c2 into x, and derivative of sin x is cos x. So dy by dx equals to c1 plus c2 into x. Derivative of e to the power of minus 2x is e to the power of minus 2x into minus 2, and the derivative of c1 plus c2 into x is just c2 plus cos x. Now given that, so y dash equals 0 when x equals to 0, then here 0 equals to c1 value already we completed, that is 1 plus c2 into 0, e to the power of minus 2 into 0 into minus 2 plus e to the power of minus 2 into 0 into c2 plus cos 0. So 0 equals to here c2 into 0 is 0 and e to the power of minus 2 into 0 is 1. So here 1 will come, and 1 into minus 2 is overall minus 2. Next plus c2, because e to the power of 0 is 1 and cos 0 is 1, then it is implies c2 equals to 1, because minus 2 plus 1 is minus 1, minus 1 transpose to left side. Now substitute c1 and c2 values in this general solution. So then y will becomes c1 value 1 and c2 value also 1. So 1 plus x e to the power of minus 2x plus sin x is our required answer. This is our required answer. 22nd question, d to the power of 4 minus 81 into y equals to cos 3x plus sin h 3x. So the auxiliary equation is m to the power of 4 minus 81 equals to 0. So here m square whole square minus 9 square equals 0. A square minus b square formula, that is a plus b into a minus b, it is equals 0. M square plus 9 equals 0. M square minus 9 equals 0. Here m square equals to minus 9. Here m square equals to 9. Here m equals to root minus 9. Here m equals to root 9. Here m equals to plus or minus I into 3. Here m equals to plus or minus 3. So here two roots are real and different, and remaining two roots are complex numbers. So then the complementary function is, so c1 into e to the power of m1x plus c2 into e to the power of m2x for the real roots, and for the complex roots e to the power of alpha x bracket of c3 into cos beta x plus c4 into sin beta x. So the complementary function is c1 into e to the power of minus 3x plus c2 into e to the power of 3x plus e to the power of alpha. Here this value compare with alpha plus or minus I beta, then alpha value 0 and beta value is 3. So substitute these values. So 0 into x, c3 into cos 3x plus c4 into sin 4x. Then the complementary function is c1 into e to the power of minus 3x plus c2 into e to the power of 3x plus e to the power of 0 into x is 1, then c3 into cos 3x plus c4 into, here 3 sin 3x is a complementary function. Now the particular integral is x divided by f of d. So x value cos 3x divided cos 3x plus sin h3x by f of d to the power of 4 minus 81. Now split into two fractions, cos 3x by d to the power of 4 minus 81 plus sin h3x divided by d to the power of 4 minus 81. Now it is equals to cos 3x divided by d to the power of 4 can write as a d square whole square minus 81, next to plus sin h3x formula, sin hax formula e to the power of ax minus e to the power of minus ax by 2. So then here e to the power of 3x minus e to the power of minus 3x by 2 by d to the power of 4 minus 81 square, that is d square plus 9 into d square minus 9. So plus 1 by 2 bracket of e to the power of 3x minus e to the power of minus 3x divided by d to the power of 4 minus 81. So it is equals to cos 3x. Now substitute d square equals to minus 9 only in this. Okay, so d square plus 9 into here minus 9 plus 1 by 2 bracket of, here we can split into two fractions, then after we have to substitute the x coefficient in the denominator at the place of d, but we are getting 0 answer in the denominator, even 3 and minus 3. When you're getting the denominator is 0, we know very well we have to do derivative with respect to capital d to the power of 4 minus 81 and multiply with x. So it is equals to cos 3x by minus 9 minus 18 d square plus 9 can write as a 3 square plus 1 by 2 bracket of here x by 2 bracket of e to the power of 3x minus e to the power of minus 3x divided by 4d cube. So it is equals to minus 1 by 18. Here apply the one formula, that is d square cos ax divided by d square plus a square equals to x by 2a into sin ax. Okay, so as for this formula, x by 2a, 2 into 3 sin ax, that is sin 3x plus x by 2. Now split into two fractions, e to the power of 3x by 4d cube minus e to the power of minus 3x by 4d cube. So it is equals to minus x by 2 3s are 6, so 18 into 6 4, here 108. So 108 into sin 3x plus x by 2 into e to the power of 3x by 4 into substitute d equals to 3, so 3 cube minus e to the power of minus 3x by 4 into minus 3 whole cube. So it is equals to minus x by 108 into sin 3x plus x by 2 into e to the power of 3x by 3 cube 27, 27 4s are 108 and 3 cube minus 3 cube is minus 27, minus 27 into 4 minus 108, and in the numerator already minus there, so plus e to the power of minus 3x by 108. So it is equals to minus x by 108 into sine 3x plus, here x by 108, take it as a common, e to the power of 3x plus e to the power of minus 3x by 2. So it is equals to minus x by 108 sine 3x plus, do one thing, take the minus x by 108 common, so bracket of sine 3x minus, so let's take the plus x by 108. To get the textbook answer, we need to take the plus x by 108 common, then minus sine 3x plus, here e to the power of 3x plus e to the power of minus 3x by 2 is cos h3x. So this is a particular integral. Now the general solution is complementary function plus particular integral. Here is a complementary function, and here is a particular integral x by 108 bracket of, first I am writing the positive term, next write the negative term. So this is our required answer.